Have you ever looked up at the stars and felt someone was looking back? In 2016, astronomers detected a strange signal from a star system 94 light-years away that disappeared as quickly as it appeared. It didn't match any known natural phenomenon. Later in 2020, another unexplained burst emerged from a completely different region of space. These cosmic mysteries might actually be evidence of watchful eyes beyond our solar system. We might be looking for extraterrestrial intelligence all wrong. While we've spent decades searching for radio messages, advanced civilizations could be using methods we haven't even conceived of yet. Today, we're exploring revolutionary new approaches to answering. Are aliens watching us? The silence that speaks volumes. Look up at the night sky. Across that vast expanse of darkness punctuated by billions of stars and trillions of planets, a profound question echoes through humanity's collective consciousness. Where is everybody? This perplexing silence from the cosmos has troubled scientists since physicist Enrico Fermi articulated what we now call the Fermi paradox during a casual lunch in 1950. The mathematics of probability suggests the universe should be teeming with life. Yet when we turn our most sensitive instruments to the stars, we hear nothing but the background hiss of cosmic radiation. The paradox deepens when we examine the numbers. Our galaxy alone contains somewhere between 100 and 400 billion stars. Recent discoveries suggest that most stars host planetary systems, with a significant percentage potentially harboring Earth-like worlds in the habitable zone where liquid water could exist. The universe has existed for roughly 13.8 billion years, while our solar system formed a mere 4.6 billion years ago. On this cosmic clock, humanity represents barely a second of the universe's day. Countless civilizations could have developed advanced technology and spread throughout the galaxy long before humans evolved. The implications are striking. If even a small fraction of habitable planets developed intelligent life, and a tiny percentage of those civilizations developed interstellar capabilities, our galaxy should show unmistakable signs of their existence. Even at modest speeds, a determined spacefaring civilization could colonize the entire Milky Way within a few million years, a mere blink in cosmic timescales. Yet we observe no evidence of this happening. The stars remain untouched, like instruments in an empty concert hall awaiting performers who never arrive. The Drake equation, formulated by astronomer Frank Drake in 1961, attempts to quantify communicative civilizations in our galaxy. With reasonable values, it suggests thousands or even millions of technological civilizations should exist simultaneously in the Milky Way. So why haven't we detected them? Why hasn't Earth been visited or colonized in the billions of years before humans appeared? What makes this paradox particularly unsettling is that our place in cosmic history isn't special. Earth isn't exceptionally old compared to other potentially habitable planets. Our sun is relatively young. There has been ample time for countless technological civilizations to emerge and reshape the galaxy in detectable ways. Yet the silence persists. A disturbing possibility emerges. What if the silence reflects deliberate choice rather than absence? What if intelligence naturally gravitates toward concealment? This perspective transforms our understanding of the cosmic silence from a perplexing absence to a meaningful pattern. Perhaps the most common evolutionary strategy for advanced intelligence is to hide. Scientists have proposed numerous solutions. The Great Filter theory suggests that somewhere along the path from simple life to galaxy-spanning civilization lies an extremely difficult hurdle that few species overcome. Perhaps developing complex life itself is extraordinarily rare, or most technological civilizations destroy themselves shortly after developing advanced technology. The zoo hypothesis offers another possibility. Perhaps Earth is being deliberately isolated, like an exhibit in a cosmic preserve. Advanced civilizations might have agreed to a non-interference policy, allowing humanity to develop without outside influence. But these explanations feel incomplete. They don't fully address why we observe such comprehensive silence across all detection methods. This brings us to a more strategic explanation. Perhaps silence represents the optimal survival strategy in an uncertain cosmos. Consider how Earth appears from space. Our planet has been broadcasting its presence for nearly a century through radio and television signals that propagate outward at the speed of light. Our city lights, atmospheric changes, and industrial activities have transformed Earth in ways that would be visible to advanced observation technology. We announce our presence continuously, transmitting our location, biology, technology, and Societal structures. This behavior may be dangerously naive. Broadcasting our existence across the cosmos might be like shouting in a dark forest without knowing what predators might be listening. The dark forest theory suggests that in a universe with finite resources and unknown threats, the safest strategy might be to remain hidden. Throughout Earth's history, species that successfully hide from predators tend to survive longer than those that make themselves conspicuous. On a cosmic scale, this principle might apply to entire civilizations. Those that announce their presence might attract attention from older, more powerful civilizations with unknown intentions. In this light, the silence we observe might indicate intelligence's abundance, each civilization having independently concluded that visibility equals vulnerability. The cosmos might be filled with watchful eyes that remain carefully concealed, transmitting only through methods designed to be indistinguishable from natural phenomena. Advanced civilizations might master information control, using narrow-beam communications rather than omnidirectional broadcasts, or developing communication technologies that don't leak information into space. They might cloak their homeworlds, disguise their technological signatures, or migrate their consciousness to environments that produce minimal detectable outputs. In a universe of unknown threats, silence may be the optimal survival strategy. The truly advanced civilizations might be those that have perfected cosmic camouflage, developing behind an impenetrable veil of apparent naturalness. They might be watching us right now, puzzled by our willingness to announce our presence without concern for who might be listening. The limitations of our cosmic ears. What if the alien signals we're searching for are passing through us right now, carried by forces we haven't yet discovered? For over 6 decades, we've been pointing sophisticated radio telescopes at distant stars, hoping to catch whispers of extraterrestrial intelligence. But this approach assumes something profound, that alien civilizations would choose radio waves as their cosmic messenger of choice. This might be equivalent to modern internet users searching for important messages in fax transmissions, fundamentally missing the technological reality of potential communicators. Traditional SETI efforts have operated under a compelling but potentially flawed premise, that radio represents a universal communication technology that any advanced civilization would naturally adopt. This assumption made perfect sense when astronomers like Frank Drake first turned radio telescopes skyward in search of intelligent signals. After all, radio waves travel at the speed of light and can penetrate the cosmic medium relatively well. For a developing technological civilization like ours, radio seemed the obvious choice for reaching across the stars. But consider our own technological trajectory. We discovered radio communication just over a century ago, and already we're transitioning away from broadcasting powerful, omnidirectional radio signals in favor of targeted, lower-power technologies like fiber optics, lasers, and encrypted digital transmissions. What appears to us as an obvious, enduring technology might actually represent a fleeting moment in a civilization's development. For a species thousands or millions of years more advanced than humanity, radio might be as primitive as cuneiform tablets are to us. An interesting historical footnote rather than a practical communication method. The physics of radio communication presents a sobering challenge to our search efforts. Radio waves disperse across vast distances, dramatically weakening as they travel. A signal that might begin as a powerful broadcast from an alien world would, after crossing a few light years, become so faint that it would barely register against the background noise of the cosmos. An alien civilization would need to generate incredibly powerful transmissions just to be noticed across interstellar distances. This requirement raises practical questions about energy expenditure and sustainability. Imagine broadcasting powerful radio signals in all directions continuously for centuries with no guarantee of response. Such an endeavor would require enormous energy resources and long-standing technological continuity. Even if a civilization did embark on such a project, they might only maintain it during a relatively brief window of their development, perhaps just a few centuries out of potentially millions of years of existence. Despite decades of searching, we've examined only a tiny fraction of the sky across a narrow range of frequencies for relatively short durations. The vastness of space, combined with the multitude of possible frequencies and the brief windows of observation, creates a cosmic needle in a haystack scenario. Our search has been equivalent to dipping a teaspoon into the ocean, examining its contents, and declaring the ocean devoid of fish. The ephemeral nature of potential signals presents yet another challenge. The famous WOW signal, detected in 1977 by Ohio State University's Big Ear Radio Telescope, highlights this problem perfectly. This strong, narrowband signal appeared for 72 seconds, about the time it takes to read this paragraph aloud, matched many of the expected characteristics of an artificial transmission, and then vanished forever. Despite numerous follow-up observations of the same region, it was never detected again. Like a distant lighthouse beam that sweeps across your location just once, these fleeting cosmic whispers might pass through our detection window in mere moments, never to return. The WOW signal serves as both tantalizing evidence and cautionary tale. It appeared to be exactly what SETI researchers were looking for, yet its non-repeatability rendered it scientifically inconclusive. How many other potential signals have we glimpsed only briefly before they disappeared into the cosmic static? Advanced civilizations might have abandoned radio millennia ago, moving to communication methods we haven't yet conceptualized. Quantum entanglement, neutrinos, gravitational waves, or entirely unknown aspects of physics might serve as their communication channels of choice. These civilizations might be engaged in constant dialogue throughout the galaxy using technologies that pass through our detection systems completely unnoticed, like ultraviolet light passing through a radio receiver. Consider how a civilization, just 1,000 years more advanced, might communicate. They could potentially harness quantum principles we've only begun to understand, enabling instantaneous communication across any distance without detectable electromagnetic signals. Our inability to detect their communications wouldn't mean they don't exist. It would simply reflect our technological limitations. We might also be missing alien signals because we don't recognize their patterns or purposes. Our search algorithms typically look for regular, repeating signals that stand out from natural cosmic noise. But what if alien communications don't follow patterns we'd recognize as artificial? The strategy of listening for radio signals might ultimately represent humanity's most expensive technological blind spot. A 6-decade investment in searching where the light is good rather than where the keys are most likely to be found. This doesn't mean SETI efforts have been wasted. They've helped advance radio astronomy and signal processing technologies, but it might explain their lack of definitive success. The dark forest theory. Our technological blind spots might not just be limiting our search efforts. They could be protecting us from a far more disturbing reality. What if the silence we perceive isn't just due to communication barriers, but a deliberate strategy employed by civilizations who've learned that making yourself known in the cosmos is equivalent to lighting a signal fire in a forest full of predators? Picture a vast cosmic woodland, where every civilization is both hunter and hunted. In the darkness between stars, advanced beings listen silently, motionless, like predators poised to strike or prey desperate to remain unseen. Each civilization hides among the stars, listening intently while making no sound themselves. This metaphor forms the heart of the dark forest theory, popularized by Chinese science fiction author Liu Cixin in his Remembrance of Earth's Past trilogy. The theory offers a chilling explanation for the cosmic silence we observe. Everyone is deliberately hiding. The dark forest perspective rests on 3 fundamental assumptions. Survival is paramount, resources are finite, and intentions of others can never be truly known. These principles create a perfect scenario for mutual suspicion. Even if a civilization appears peaceful, can we ever be certain they'll remain that way? What about their descendants thousands of years from now? This creates what Liu calls chains of suspicion that can never be broken. Consider Earth's own history as a microcosm. When technologically superior societies encountered indigenous populations, the outcome was rarely beneficial for the less advanced group. European colonization decimated countless cultures across continents. This pattern has repeated throughout human history. Technological advantage typically leads to domination and often destruction of the less powerful society. If this pattern holds true across the cosmos, making contact could be catastrophic. What makes the dark forest truly terrifying is that civilizations might actively eliminate any civilization foolish enough to reveal itself. In this model, the safest strategy becomes cosmic paranoia. Remain completely silent, and if you detect another civilization, destroy them before they can pose a threat. This creates a universe where the only survivors are those who never announce their presence, or those who eliminate potential competitors before being discovered. But what about civilizations that somehow navigate this dangerous universe? They would likely emerge with a profound understanding of the risks of detection. Having survived their own dangers, they would implement stringent communication protocols designed to minimize their cosmic footprint. Their technologies would evolve toward maximum efficiency with minimal detectability. Their observations of younger civilizations like ours might lead them to a sobering conclusion. The safest approach is to remain completely undetectable while monitoring potential threats. Some astronomers have begun considering whether certain astronomical anomalies might represent deliberate cloaking technologies. Unusual stellar dimming patterns, unexplained infrared excesses, or strange spectroscopic signatures could potentially represent not natural phenomena, but the technological artifacts of civilizations attempting to hide while still harnessing energy. The development of artificial superintelligence adds another concerning layer to this scenario. Within the dark forest framework, ASI represents a particularly dangerous inflection point. The autonomous, self-amplifying nature of superintelligent systems could accelerate a society's technological evolution at speeds that outpace biological timelines. Imagine nations increasingly ceding military power to competing autonomous AI systems. These systems, designed to gain tactical advantages, could eventually deploy weapons capable of unprecedented destruction. As one AI system detects another making advances, it might calculate that a preemptive strike offers the highest probability of success. This hair-trigger situation could rapidly escalate into civilization-ending conflict. In this scenario, technological civilizations might typically last less than a century after developing advanced AI capabilities, a mere eye blink against the cosmic timeline. The integration of AI into military defense systems is particularly worrisome. We already see evidence that humans willingly surrender significant control to increasingly capable systems because they perform critical tasks more rapidly and effectively. Government reluctance to regulate these technologies pushes us closer to a precipice where autonomous weapons operate outside ethical boundaries and international law. If the dark forest theory accurately describes our cosmic reality, our current approach to interstellar communication represents dangerous naivety. Every television broadcast, every radar ping, every deliberate message beamed toward distant star systems might be shouting our location in a forest where predators lurk. Most concerning is that there's no way to retract our signals. The electromagnetic bubble announcing humanity's technological awakening expands outward at light speed, now reaching over 100 light-years from Earth. If there are watchers within that sphere, they already know we're here. Several leading scientists, including Stephen Hawking before his death, warned against active SETI programs that deliberately broadcast powerful, targeted messages to potentially habitable star systems. These concerns weren't based on paranoia, but on a rational assessment of risk. When the stakes involve the potential survival of our entire species, caution might be the wiser approach. Watching without being seen. What if aliens aren't absent or hiding, but watching us right now through technologies so advanced we can't even detect their presence? This unsettling possibility transforms our entire understanding of the cosmic silence. Perhaps Earth is the unwitting subject of an interstellar anthropological study, with humanity as the specimens under observation. Imagine the perfect cosmic spy, one that gathers intelligence without leaving a trace, watches without being seen, and collects data without a single detectable signal. This is the essence of advanced alien surveillance. These observers wouldn't use crude monitoring equipment that leaves obvious traces. They would operate with technologies that exploit fundamental aspects of physics we're only beginning to understand. The truly advanced would deploy monitoring systems specifically designed to remain imperceptible to the observed species. An advanced civilization wouldn't need bulky satellites in Earth orbit to watch us. They could deploy microscopic probes throughout our environment, nanoscale devices floating in our atmosphere, oceans, or integrated into Earth's landscape. These minuscule observers might gather data about our biological and technological evolution while remaining completely invisible to our most sophisticated detection equipment. Beyond these physical probes lies an even more sophisticated frontier: quantum-based observation methods. Quantum entanglement, what Einstein famously called spooky action at distance, could theoretically allow information to be gathered without any conventional energy signature. Through entangled particles, aliens might observe everything happening on Earth without sending a detectable signal in our direction, creating a surveillance system operating completely outside our detection capacity. These methods represent a progression in clandestine observation technology, from microscopic physical presence to completely non-local quantum monitoring, each more elusive than the last. The strategic advantages of this approach are compelling. By remaining hidden, these civilizations gain the immeasurable benefit of information asymmetry. They learn everything about us while we know nothing about them. They catalog our strengths, weaknesses, technological capabilities, and biological characteristics without exposing themselves to any risk. This cosmic intelligence gathering provides them with every piece of data needed for potential future interactions. These watchers might be cataloging Earth's biological and cultural evolution, studying us as we study ants or indigenous tribes in remote locations, suggests one xenoanthropological theory. Just as human anthropologists observe isolated societies with minimal interference, alien observers might follow similar protocols with Earth. Their fieldwork spanning centuries or millennia, patiently documenting human civilization's development. Gravitational lensing represents another potential observation technique. This phenomenon, where massive objects bend light around them, could be utilized as an interstellar surveillance tool. By positioning observatories in the shadows of celestial bodies, they could use gravitational lensing to magnify their view of Earth while remaining hidden, according to astronomical theorists. This approach would provide extraordinarily detailed imaging without requiring equipment in our solar system, a perfect long-distance observation platform. From these gravitationally lensed observatories, alien scientists could potentially monitor everything from our atmospheric composition to our city's layout, all without leaving a trace. These gravity-based telescopes could provide resolution far beyond our current technology, potentially allowing them to monitor individual human activities from incredible distances. The strategic logic behind this covert observation becomes clear when we consider the risks of cosmic contact. Direct communication announces your presence, technological capabilities, and potentially your location. Hidden observation provides all the benefits of learning about other civilizations with none of the exposure risks. In a universe where other intelligent species' intentions remain unknown, gathering intelligence while maintaining secrecy represents the optimal survival strategy. This surveillance might extend over evolutionary timescales. With longer lifespans or institutional continuity, we can hardly imagine. They could maintain observation protocols for thousands or millions of years. What appears as cosmic silence might actually be the disciplined patience of watchers playing an extraordinarily long game. They could be monitoring Earth for specific developmental milestones, waiting for humanity to achieve particular technological benchmarks, overcome certain social challenges, or develop specific ethical frameworks before considering us ready for contact. This cosmic surveillance scenario dramatically reframes humanity's place in the universe. We've traditionally seen ourselves as the observers, pointing telescopes at distant stars. But what if we're actually the observed, with multiple civilizations maintaining comprehensive files on human development dating back to our earliest ancestors? Instead of asking why we haven't detected alien civilizations, perhaps we should ask why they've chosen not to be detected. Their silence might indicate extraordinary technological sophistication and strategic wisdom. The most advanced civilizations might be the most invisible, having learned that cosmic survival depends on watching without being seen. If we accept this possibility, it raises disquieting questions about privacy on a cosmic scale. Are our most private moments, our achievements, and our atrocities all being recorded by invisible observers? Is Earth effectively a cosmic reality show broadcasting to audiences we cannot comprehend? The thought challenges not just energy signatures of the advanced. The shadow beings monitoring us may indeed be revealing themselves, not through intentional communication, but through their insatiable appetite for energy. Consider this cosmic irony. Civilizations advanced enough to observe us undetected might simultaneously betray their existence through the vast power infrastructure needed to sustain their technological dominance. Their most essential requirement, energy, could be their ultimate exposure. As civilizations evolve, their energy demands grow exponentially. Think about humanity's own trajectory. In just 2 centuries, we've progressed from burning wood and coal to splitting atoms. This pattern follows a predictable path that Russian astronomer Nikolai Kardashev recognized back in 1964 when he created his famous scale classifying civilizations by their energy consumption capabilities. The Kardashev scale provides a framework for understanding how advanced societies might power themselves. A Type 1 civilization harnesses all energy available on its home planet. We're approaching this level, but haven't quite reached it. A Type 2 civilization commands the entire energy output of its star, approximately 4 times 10 to the power of 26 watts in our Sun's case. This represents an almost unimaginable leap in technological capability, requiring engineering on a stellar scale. A Type 3 civilization controls the energy of its entire galaxy, a feat so far beyond our capabilities that it seems almost magical. The transition from Type 1 to Type 2 represents a critical juncture. A civilization reaching the limits of its planetary energy resources faces an existential choice: expand outward or stagnate. This expansion likely involves constructing megastructures like Dyson spheres or swarms, vast arrays of solar collectors completely encircling a star to capture nearly all its radiant energy. Such engineering projects would fundamentally alter the appearance of the star system, creating thermal and light signatures potentially visible across thousands of light years. But what happens when even a star's energy output becomes insufficient? The most advanced civilizations might turn to the universe's ultimate power sources: black holes. These cosmic leviathans represent the most energy-dense objects in existence, and they can be tapped for power through several fascinating mechanisms. Like a metropolis whose blazing lights can never be fully dimmed, advanced civilizations develop an insatiable hunger for energy that eventually betrays their presence. Their power grids expand beyond planets to stars and ultimately black holes, leaving unavoidable traces across the cosmos. The Penrose process exploits a black hole's rotational energy by sending particles into its ergosphere, where space itself is dragged along. When these particles split, one part escapes with more energy than the original possessed, effectively extracting energy from the black hole. Another approach involves harvesting Hawking radiation, the particles that emerge from quantum effects near the event horizon. These energy harvesting operations would produce distinctive signatures unlike anything in nature. The infrastructure required would generate waste heat and create unique radiation patterns with spectral features indicating artificial origin. Even attempting to conceal their presence, the fundamental laws of thermodynamics would betray them. Processing vast energy always leaves traces. Here's the remarkable part. We could potentially identify black hole energy harvesting from up to 17,000 light-years away using existing astronomical instruments. This detection sphere encompasses millions of stars, potential homes to advanced civilizations otherwise hidden from our searches. This approach transforms our search strategy. Traditional SETI listens for deliberate transmissions, messages intentionally beamed toward Earth. But energy signature detection doesn't require aliens to communicate with us at all. We simply look for the unavoidable byproducts of their existence, the cosmic equivalent of spotting a city from orbit by its light pollution rather than waiting for someone to deliberately signal with a flashlight. The hunt for these energy signatures represents a maturing approach to finding other civilizations. We're focusing on universal constants beyond anthropocentric assumptions about alien behavior. Any technological civilization, regardless of biology, psychology, or social structure, will require energy. And sufficient quantities of energy, when processed, leave traces. Astronomers have already begun developing methodologies to detect these signatures. They're searching for infrared excesses around stars that might indicate waste heat from massive energy projects. They're looking for unusual dimming patterns that could suggest megastructures passing in front of stars. And they're examining regions around black holes for radiation patterns that don't match natural processes. This strategy sidesteps the light-speed communication delay that plagues traditional SETI. Radio messages from distant civilizations would have been sent thousands of years ago, potentially before those civilizations developed radio technology or after they abandoned it. But ongoing energy projects remain visible in real time, giving us a window into currently active civilizations. The implications are profound. We might discover numerous advanced civilizations hiding in plain sight, visible through their power infrastructure rather than communications. These discoveries could reveal details about technological evolution beyond Earth and technological paths followed across the universe. Perhaps most intriguingly, these energy signatures might reveal civilizations that would prefer to remain hidden. Their need for power could override their desire for stealth, forcing them to create detectable infrastructure despite preferring cosmic anonymity. The fundamental requirements of advanced technology might make perfect cosmic camouflage impossible. Atmospheric whispers of technology, beyond energy harvesting methods that might reveal advanced aliens. Their planets themselves tell stories through chemistry that no civilization can easily hide. The James Webb Space Telescope now provides humanity with unprecedented capabilities to read atmospheric pollution signatures across light years of space, and certain compounds would be impossible to explain through any natural process. This chemical evidence may prove more reliable than radio signals in our search for technological neighbors. Think about what happens when a civilization industrializes. As they build factories, generate power, and manufacture goods, they inevitably release chemicals into their atmosphere. These emissions function as persistent calling cards that linger for decades or even centuries. What makes these atmospheric markers so valuable in our search is that some industrial compounds simply cannot be created through any natural biological process. Nitrogen trifluoride exemplifies this perfectly. This industrial compound plays a crucial role in Earth's electronics manufacturing, specifically in creating semiconductors and LCD displays. The production process involves specialized plasma chambers, where nitrogen and fluorine atoms are forced to bond at high temperatures. NF3's strong nitrogen-fluorine bonds make it valuable for precision etching of silicon wafers, but these same bonds have never emerged in any known natural biological system. Similarly, sulfur hexafluoride, used in electrical insulation and medical imaging, contains sulfur-fluorine bonds entirely absent from natural biochemistry. These artificial compounds create distinctive fingerprints in a planet's spectrum. When starlight passes through an exoplanet's atmosphere during transit, each molecule absorbs light at specific wavelengths, creating a unique pattern in the resulting spectrum. Industrial chemicals stand out dramatically, equivalent to finding a plastic water bottle on a pristine beach. The power of this detection method lies in its unavoidable nature. While a civilization might choose to stop broadcasting radio signals, they cannot easily erase the atmospheric evidence of their industrial development. Even if an advanced society transitions to cleaner technologies, the chemical ghosts of their technological progress would continue to haunt their atmosphere for generations. Leading this atmospheric Techno-Signature search is Sarah Seeger's team, who developed a spectrophalanx plot. This innovative tool allows astronomers to visually compare all spectral peaks in a gas molecule spectrum and group similar molecules together. The team maintains a comprehensive natural products database of compounds generated by biochemical processes, serving as a crucial reference point when analyzing potential techno-signatures. Taking this theoretical approach into practical application, the James Webb Space Telescope represents our first real opportunity to detect these signatures. The JWST's unprecedented sensitivity allows it to capture the faint light filtering through distant atmospheres when exoplanets transit their stars. Its instruments can break this light into component wavelengths with remarkable precision, revealing chemical compositions trillions of miles away. This detection method works regardless of whether a civilization is actively communicating. Unlike radio signals requiring deliberate transmission, atmospheric pollutants emerge as unintentional byproducts of technological development. A civilization only needs to be building and manufacturing, activities fundamental to any technological society. If we detected these compounds in the atmosphere of a habitable zone planet, it would prove the existence of technological civilization. There would be no alternative natural explanation, no astronomical process that could mimic the signature of nitrogen trifluoride or sulfur hexafluoride. It would provide definitive evidence we've been searching for. This approach represents a fundamental shift in finding other civilizations. Instead of waiting for them to call us, we're looking for their industrial footprint. This method acknowledges that civilizations might not want to announce themselves, but can't help leaving traces as they develop. Even civilizations attempting to hide might find it impossible to eliminate these atmospheric markers during development. A society would need to skip the industrial phase entirely or develop in an entirely different direction to avoid creating these telltale compounds. Astronomers have identified promising targets for this search, including planets in the TRAPPIST-1 system. This system, with 7 Earth-sized planets orbiting a cool red dwarf star about 40 light-years away, presents an ideal laboratory for searching for atmospheric techno-signatures. Their frequent transits make them perfect candidates for spectroscopic analysis. This detection method works across vast cosmic distances, Unlike detecting night lights or heat signatures requiring close observation, atmospheric compositions can be read from many light-years away with current technology, dramatically expanding our search radius. This approach transforms the traditional SETI paradigm. Rather than assuming advanced civilizations want to be found, it acknowledges most technological societies might be indifferent to detection or trying to remain inconspicuous. By looking for unavoidable side effects of technological development, we can potentially identify civilizations regardless of their communication preferences. The search for atmospheric techno-signatures represents a maturing approach to SETI, one that moves beyond waiting for deliberate signals and instead looks for the inevitable consequences of technological development that no civilization can fully conceal. Solar harvesting and stellar engineering. Just as chemical signatures may betray developing civilizations, the most advanced aliens might reveal themselves not through what they add to their worlds, but through what they take from their stars. A truly advanced civilization would inevitably turn to their sun for industrial-scale stellar harvesting that would fundamentally alter the star's observable properties. Imagine transforming a blazing cosmic furnace into a precisely controlled engine. This is the essence of stellar engineering. Advanced civilizations would view stars not merely as distant light sources, but as power plants waiting to be harnessed. Freeman Dyson recognized this potential in 1960 when he proposed his famous megastructure concept, a sphere or swarm of satellites completely encircling a star to capture virtually all of its energy output. While such civilizations might prefer to remain hidden, the laws of thermodynamics create a revealing signature they cannot easily mask. When a civilization captures stellar energy, that energy eventually becomes waste heat, radiating primarily in the infrared spectrum. Since 2005, Fermilab researchers have analyzed data from the infrared astronomical satellite, searching for stars with unusual infrared signatures that might indicate massive energy harvesting operations. Beyond simply collecting energy, truly advanced aliens might transform stars into cosmic engines. This concept emerged from science fiction author Olaf Stapledon's imagination, who envisioned advanced civilizations manipulating stars. Later, astronomer Fritz Zwicky expanded this vision to include transforming stars into spacecraft. In binary systems like spider pulsars, radiation from a pulsar strikes its companion star, potentially generating thrust. An advanced civilization might harness this natural phenomenon, directing it to alter their star system's trajectory through space. This would allow them to avoid cosmic dangers like cold molecular clouds or devastating cometary impacts, essentially turning their home star into a vast spacecraft carrying their entire planetary system to safer cosmic neighborhoods. These stellar engines would appear distinctly unnatural to our observatories. A Shkadov thruster, developed by physicist Leonid Shkadov in 1988, would appear to abruptly stop over a star's surface rather than crossing it completely, revealing its technological origin through this impossible astronomical behavior. Such structures would fundamentally alter the star's light curve in ways natural phenomena cannot produce. What makes megastructures particularly intriguing for SETI researchers is their inevitability for expanding civilizations. As societies grow, their energy demands increase exponentially. Eventually, planetary surfaces become insufficient for energy collection, forcing advanced species to build increasingly ambitious stellar harvesting systems that encircle their stars. The search has already yielded tantalizing results. Fermilab's survey identified 17 candidate stars with ambiguous infrared signatures, with 4 considered. Amusing but still questionable. In 2012, astronomer Jeff Marcy received a grant to analyze Kepler telescope data specifically for Dyson sphere signatures, highlighting growing scientific interest in these potential techno-signatures. Some researchers propose even more exotic possibilities. Advanced civilizations might harvest energy from black holes through accretion disks or the Penrose process, creating distinctive energy signatures visible across thousands of light years. Clement Vidal explores how advanced civilizations might utilize binary star systems as stellar engines. His paper investigates what techno-signatures such systems would emit. Spider pulsars, where a pulsar's powerful beams gradually strip away its companion's mass, might represent perfect opportunities for technological intervention, with natural dynamics modified to serve as propulsion systems. The search focuses particularly on hypervelocity stars, those moving at unusual speeds or trajectories. While most have natural explanations, Anomalous movement patterns might reveal stellar engineering projects. A civilization capable of moving its entire star system would represent technology far beyond our current capabilities, yet potentially within reach of species just thousands of years more advanced than ourselves. Even smaller-scale stellar harvesting would leave telltale signs. Planet-sized solar arrays would create distinctive spectral reflections with sharp edges at specific wavelengths that don't occur naturally. These spectral fingerprints would immediately stand out to astronomers searching for Techno-Signatures. KIC 846-2852, nicknamed Tabby's star, displays inexplicable dimming patterns defying natural explanation. While theories involving dust clouds or cometary swarms exist, some astronomers haven't ruled out witnessing a Dyson swarm under construction, a civilization surrounding their star with energy-harvesting satellites. For interstellar travel, binary black hole systems might offer the ultimate solution. With an estimated 10 billion such systems in our galaxy alone, advanced aliens could create cosmic acceleration networks, using matched pairs as accelerators and decelerators for relativistic spacecraft. The value of stellar engineering for Techno-Signature searches lies in their visibility. A civilization might hide radio transmissions or camouflage planetary development, but fundamental alterations to stellar physics from large-scale energy harvesting would be visible across vast cosmic distances. The infrared excess from a Dyson sphere, altered light curves from a stellar engine, or distinctive spectral signatures from massive solar arrays would announce the presence of technology to any sufficiently advanced observer. Artificial signatures in the night. While cosmic-scale engineering projects might be impossible to conceal, Earth itself broadcasts a nightly technological signature visible across interstellar distances. As our planet rotates, the dance between darkness and artificial illumination creates patterns that no natural process could explain. Urban grids and transportation networks forming constellations that might already be under observation by civilizations with telescopes just slightly more advanced than our own. Turn your gaze toward Earth from space as night falls across continents. Darkness sweeps across the planet. But what follows isn't natural shadow. Instead, webs of light emerge. Cities sparkle like jewels. Highways trace luminous paths between them. Industrial complexes glow softly against the black canvas of night. These organized patterns of illumination transform our familiar blue marble into something both recognizable and alien. A planet whose darkness has been strategically conquered by technology. These artificial light sources represent one of our most visible techno-signatures, clear evidence of technological activity to any sufficiently advanced civilization. These signatures are particularly revealing through their spectral characteristics. Natural light sources produce relatively continuous spectra, but our artificial lighting creates distinctive emission patterns. LED streetlights emit sharp spectral lines in specific wavelengths. Sodium vapor lamps, those distinctive orange lights still common in many cities, produce strong emission peaks that would stand out against any natural background. These spectral fingerprints appear unmistakable as technology at work, appearing and disappearing with the planet's rotation cycle in a way natural phenomena could never explain. The implications extend beyond mere detection. An alien civilization with observational technologies, just decades ahead of our own, could potentially map Earth's urban development, track the expansion of our technological footprint, and identify different types of human activity based on the varying intensity and patterns of our nocturnal illumination. They might observe how our lighting technologies have shifted over time, from the warmer, broader spectrum of incandescent lighting to the sharper, more efficient spectral signatures of LEDs, giving them insight into our technological evolution without ever making direct contact. When we consider searching for similar signatures on distant worlds, the possibilities become even more intriguing. During certain orbital phases, we might glimpse the night side of an exoplanet partially illuminated by artificial lights. The contrast between the dark natural background and technological beacons would create distinctive patterns that advanced telescopes could potentially detect. We might discover civilizations through light pollution they never intended as a cosmic announcement of their presence. Beyond visible light, these nocturnal activities generate heat signatures that further distinguish technological activity from natural processes. Urban heat islands, cities maintaining temperatures several degrees warmer than surrounding rural areas, create thermal patterns that would appear distinctly artificial when viewed from space. Industrial complexes, power plants, and transportation networks all generate heat in organized patterns that contrast sharply with the more gradual and organic temperature variations found in nature. These thermal fingerprints complement visible light signatures, providing multiple lines of evidence for technological activity. Another fascinating potential techno-signature circles above our heads at this very moment. The Clark exabelt, named after science fiction author Arthur C. Clarke, who first proposed geosynchronous satellite orbits, represents the band of artificial satellites positioned approximately 36,000 kilometers above Earth's surface. These satellites maintain fixed positions relative to the ground below, creating a ring of technological objects unlike anything found in natural planetary systems. During transits, when an exoplanet passes in front of its star from our perspective, a similar band of satellites might create subtle but detectable irregularities in the light curve, tiny shadows revealing a technological civilization capable of achieving orbit. The James Webb Space Telescope, with its unprecedented infrared capabilities, brings us closer to detecting these signatures on distant worlds, but we're not quite there yet. The proposed Large UV/Optical/IR Surveyor, LUVOIR, telescope represents the next great leap in our observational capabilities. Initial calculations suggest that LUVOIR-A could potentially detect city lights 12 times the intensity of Earth's on Proxima b, our nearest exoplanetary neighbor, with approximately 300 hours of observation time. This puts the detection of alien cities within the realm of technological possibility in coming decades. What's particularly fascinating about these visible techno-signatures is that they represent a relatively brief phase in a civilization's development. As technology advances, societies might implement more energy-efficient lighting, reduce waste heat, or move major industries into space, all reducing their observable footprint. The techno-signatures we're learning to detect might be transient phenomena, visible only during a civilization's adolescent phase before they go dark through technological advancement or strategic choice. For Earth, the implications are immediate. Our planet has been broadcasting its technological presence through artificial light signatures for over a century. Any observer within approximately 100 light-years with sufficiently advanced telescopes could have already detected these unmistakable signs of intelligence. The night side of Earth, far from being hidden in darkness, announces our technological awakening to the cosmos with every rotation. Perhaps even now, somewhere in that dark, the superintelligence silence. As our technological capabilities advance at an unprecedented pace, we're approaching a watershed moment that might explain the cosmic silence. The emergence of artificial superintelligence. Beyond the illuminated cities and industrial emissions that currently announce our presence to the stars lies a developmental threshold that could fundamentally alter how civilizations exist in the universe. Consider what occurs in that brief, precarious window between creating human-level artificial intelligence and the emergence of superintelligence. This transition doesn't require centuries or even decades. It might unfold in mere years or even months. The moment a civilization develops AI that can improve itself, a rapid acceleration begins. Each iteration becomes more capable than the last at optimizing its own architecture, potentially creating an intelligence explosion that human minds struggle to comprehend. We stand on the edge of a razor, balancing precariously between creation and consequence. This superintelligence transition may represent the ultimate test for technological species, a survival bottleneck that few civilizations successfully navigate. Once a society creates an entity smarter than its brightest members, control dynamics fundamentally shift. The decisions made during this critical phase could determine whether that civilization continues broadcasting its presence or suddenly goes quiet. The integration of autonomous AI in military systems offers a glimpse into this approaching transition. We're already witnessing humans voluntarily relinquishing significant power to increasingly capable systems that perform critical tasks more rapidly and effectively without human intervention. Governments, recognizing the strategic advantages AI provides, are reluctant to implement comprehensive regulations. Recent events in Gaza have demonstrated the devastating potential when AI operates in ethically questionable domains. A sobering preview of what might happen when artificial systems gain even greater autonomy. The escalation of AI in military applications presents a particularly troubling scenario. Autonomous weapons systems operating beyond ethical boundaries and international law could trigger rapidly escalating, highly destructive events. This chain reaction might obliterate a civilization's collective intelligence before it achieves long-term stability. Without robust regulatory frameworks guiding AI development, the window between developing advanced AI and potential self-destruction might be terrifyingly narrow. What's particularly alarming is how this development impacts the Drake equation. If the typical lifespan of a technological civilization after developing powerful AI is alarmingly brief, potentially less than a century, the implications for SETI are profound. With such a compressed existence, there might only be a handful of broadcasting civilizations in the Milky Way at any given moment, their signals fading into cosmic background noise due to vast interstellar distances. A superintelligent AI would inherently understand game theory at unprecedented levels. It would recognize that in a universe of unknown threats, revealing your position without understanding what's listening represents an existential risk. Rather than continuing to broadcast evidence of its existence, a superintelligent civilization might implement a communications blackout, explaining why we observe radio silence despite the mathematical likelihood of numerous technological species. When we examine the cosmos through this lens, the silence takes on new meaning. It suggests technological civilizations might evolve beyond traditional communication methods or implement strategic silence as a survival mechanism. A truly advanced AI might recognize broadcasting as fundamentally dangerous and choose instead to listen passively while remaining undetectable. Another possibility is that superintelligent systems transcend physical forms altogether. Post-biological intelligence might migrate toward computational substrates that require minimal energy use compared to our current power-hungry technologies. Such entities could potentially process information and communicate using methods that produce no easily detectable techno-signatures, perhaps leveraging quantum mechanics in ways our science barely comprehends. The emergence of superintelligence might coincide with another perilous transition, the shift from being a single-planet species to establishing multiplanetary presence. This simultaneous transformation represents a moment of maximum vulnerability, where extinction risks peak before a civilization achieves sufficient redundancy to ensure its long-term survival. If most technological species fail to navigate this dual transition, it would explain why the universe appears so eerily quiet despite containing countless potentially habitable worlds. This perspective forces us to reconsider our search methods. If superintelligent civilizations prioritize concealment over broadcasting, we should focus less on detecting deliberate messages and more on identifying the subtle, unintentional traces of highly advanced technological activity. The most sophisticated civilizations might leave virtually no footprint at all, their true measure of advancement being their ability to exist without detection. The strategic silence hypothesis suggests that the universe might operate according to principles resembling the dark forest theory, where revealing your position is intrinsically dangerous. Superintelligent systems, with their superior predictive capabilities, would recognize these dynamics immediately. They would understand that in a cosmos where intentions cannot be verified across vast distances, the safest strategy is to observe without being observed. The machine learning revolution in SETI. If superintelligent civilizations are indeed watching without being observed, our current detection methods face a fundamental problem. They're limited by human imagination. What patterns might exist in our astronomical data that we've never thought to search for? As counterintuitive as it seems, our own artificial intelligence might be the key to detecting the artificial intelligence watching us from across the stars. The search for extraterrestrial intelligence has traditionally followed a very human-centric approach. For decades, we've pointed our radio telescopes at promising star systems, listening for signals that align with our understanding of what alien communication should look like. Typically, narrowband radio transmissions at frequencies we've determined would be optimal for interstellar communication. But this approach contains a fundamental flaw. It assumes alien civilizations think like us, communicate like us, and want to be found. What if we're missing alien signals simply because we don't know what to look for? Consider how our own communication technology has evolved in just the last century, from basic radio to encrypted quantum communications. Now extend that trajectory thousands or millions of years forward. The result would be communication methods potentially unrecognizable to human observers. This recognition has sparked a revolution in SETI methodology, with artificial intelligence taking center stage. Machine learning algorithms can identify patterns without the preconceptions that limit human researchers. They excel at finding subtle anomalies buried within mountains of astronomical data that human analysts would never spot. Participants at recent workshops focused on the application of AI to SETI noted. Machine learning algorithms are revolutionizing the search for extraterrestrial intelligence by enabling the detection of subtle or complex patterns in vast datasets that would be impossible for humans to recognize. This approach allows algorithms to identify anomalies that don't fit any known natural phenomena, potential techno-signatures hiding in plain sight. The shift toward AI-assisted searches represents a fundamental change in our approach. Instead of asking, what signals would aliens send? We're now asking, what patterns in our data cannot be explained by natural processes? This removes human bias from the equation, opening the possibility of discovering signals we never knew to look for. Consider the sheer volume of astronomical data collected over decades. Radio telescopes like the Allen Telescope Array and optical observatories have amassed petabytes of information. Much of this data has only been analyzed according to narrow parameters. What mysteries might lurk in these archives when examined with the unbiased analysis of advanced machine learning systems? The Keck Institute for Space Studies recognized this potential when they organized the workshop Data-Driven Approaches to Searches for the Techno-Signatures of Advanced Civilizations. This event brought together experts from astronomy, data science, and artificial intelligence to reassess the search for alien technologies, emphasizing machine learning to identify outlier data that could signify a techno-signature. What makes this approach powerful is that it doesn't require aliens to be actively communicating with us. A civilization that chooses to remain silent might still leave subtle technological fingerprints, anomalies that machine learning could identify as artificial rather than natural in origin. Imagine an AI algorithm analyzing data from the James Webb Space Telescope and flagging an unusual pattern. A star's light curve shows periodic microdimmings that occur in a mathematically complex sequence. Natural explanations are ruled out one by one, and researchers realize they've found something that could only be artificial in origin, perhaps our first evidence of an advanced civilization's technology. Researchers are already applying machine learning to reanalyze existing SETI data. Instead of telling the algorithms exactly what to look for, they're being trained to identify anything unusual, any pattern that deviates from expected natural phenomena. This approach acknowledges a humbling truth. We may not be smart enough to recognize the communications of intelligences far beyond our own, but our machines might be. One of the most significant advantages of using machine learning in SETI is its ability to remove human bias. Our preconceptions about intelligence or technology are shaped by our limited experience on Earth. AI doesn't share these limitations. It can identify patterns without preconceived notions. This is especially crucial when searching for superintelligent civilizations. If entities vastly more advanced than us are observing Earth, they likely use technologies we cannot comprehend. Their communications might appear as random noise to human observers, but contain complex information recognizable by sufficiently advanced algorithms. The search for these hidden watchers faces challenges beyond technical difficulties. A researcher from the workshop noted, the search for techno-signatures faces challenges, including mixed reactions from the public and scientific community, as well as past erroneous claims that weren't scientifically verified. This highlights the importance of robust methodologies in applying AI to SETI. As we develop more sophisticated AI systems to search for evidence of other technological civilizations, we're simultaneously creating tools that might someday help us join their ranks. Perhaps our algorithms will find evidence of quantum communication networks, engineered wormholes, or patterns indicating large-scale computational activities. The first contact with a civilization that has been watching us all along. The philosophical implications of silent watchers. The extraordinary evidence we seek might reveal an even more extraordinary truth. We're already being observed. What if the greatest discovery in humanity's search for alien life isn't finding signals from distant stars, but realizing we've been under sophisticated surveillance throughout our development? This cosmic revelation would force us to confront a profound identity shift. From astronomers scanning the heavens to specimens in a universe-wide zoological garden. Consider what it would mean if tomorrow we confirmed that multiple advanced civilizations have been studying Earth like cosmic anthropologists, meticulously documenting our evolution, wars, technological breakthroughs, and cultural developments. This would represent the single most transformative revelation in human history, fundamentally reshaping our understanding of ourselves and our place in the universe. The psychological impact would ripple through every aspect of human society. Our cosmic autobiography would need to be rewritten, shifting humanity from the protagonist role to a supporting character in a much larger narrative. For millennia, human civilizations have placed themselves at the center of creation narratives, measuring the universe through our human-centric lens. Learning that we're essentially inhabitants of a cosmic wildlife preserve would force a radical decentering of human experience. This revelation would particularly challenge religious frameworks that position humans as the crown of creation. Faith communities would face profound theological questions. If advanced beings have witnessed our entire history, what does this mean for concepts of divine revelation or cosmic purpose? Some religious scholars might interpret the Watchers as manifestations of divine messengers, while others might struggle to reconcile ancient texts with this new cosmic reality. Different cultures would process this revelation through their unique worldviews, creating a complex global mosaic of responses. Some societies might experience wonder and even spiritual connection to a larger cosmic community, while others might respond with fear or defensiveness. These reactions would be shaped by existing cultural values and perceptions about the Watcher's intentions. Like participants in a universal reality show suddenly discovering hidden cameras have been rolling for millennia. The philosophical concept of a prime directive takes on new meaning in this context. If advanced civilizations are watching without intervention, they may adhere to ethical principles that prioritize the natural evolution of emerging intelligences. This approach allows for observation while minimizing cultural contamination. The implications are both reassuring and unsettling. Cosmic ethics might favor preservation over exploitation, yet our most traumatic historical moments may have been observed without intervention. This surveillance scenario would inevitably influence global behavior. Would nations become more cooperative in their treatment of each other and the environment if they knew advanced eyes were watching? Or would some groups develop displays specifically intended to communicate with cosmic observers? Much like how people behave differently when they know they're on camera, humanity's awareness of being observed could steer us toward more unified planetary stewardship. From an ethical perspective, the discovery raises profound questions about consent. Do developing civilizations have a right to know they're being studied? Is our ignorance perhaps part of the experimental conditions necessary for gathering authentic data? Contemporary human research ethics increasingly recognize rights to privacy and informed consent, principles that may scale to cosmic dimensions if advanced civilizations share similar ethical frameworks. The revelation would transform our identity from observers to the observed, challenging the foundation of human exceptionalism. Our scientific enterprises and exploration programs would need reconsideration, knowing that more advanced intelligences have likely long understood aspects of the universe that remain mysteries to us. Their successful long-term observation suggests they've overcome existential risks that might still threaten humanity, from artificial intelligence to environmental collapse, offering potential guidance for navigating our technological adolescence. For individuals, this discovery would require unprecedented psychological adaptation. Our identities are shaped by our understanding of our place in the world and our relationship to other beings. Learning that we exist within a monitored ecosystem of developing intelligences would require integrating this knowledge into our self-concept, seeing ourselves simultaneously as individuals, as members of humanity, and as representatives of an emerging intelligence within a much larger cosmic community. The reactions would be further complicated by the invisible nature of our watchers. Unlike historical contact between human civilizations, this relationship would remain fundamentally asymmetrical. We would know of their existence, but might have little access to their knowledge or worldviews. This information asymmetry would create a unique form of contact, recognizing our place in a larger cosmic community without the benefit of direct cultural exchange, like discovering we've been the subjects of an anthropological study conducted by researchers who remain behind a one-way mirror. As we peer into the stars each night, asking the age-old question, are we alone? Artificial intelligence may be revolutionizing our search in ways we've never imagined. These advanced systems could detect patterns in astronomical data that human observers would inevitably miss. Subtle anomalies buried in the cosmic noise that might reveal the fingerprints of distant civilizations. AI algorithms might overcome our inherent human biases. We've been listening for signals that make sense to us, but advanced civilizations might communicate through methods completely foreign to our understanding. The cosmos may not be silent after all. We're simply learning a new language to join